Good morning. So let us start. The problem is play on vendors. It is given a hacker rank. See, it's a game between two army commanders. It's a game between two army commanders. See, it's a game between two army commanders. Look at the input. There are 10 locations and 10 paths between them. Okay. There are 10 locations and 10 paths. There is a connection between 1 to 10, 3 to 10, and so on up to 2 to 8. So hope you understand it. I'll show you this with the help of a graph. Locations n is equal to 10. Number of paths m is equal to 10. Okay. So we can show the information as an adjacency matrix. These are locations 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all only one-way paths. There is no two-way path. 2, 3, 4, 5, 6, 7, 8, 9. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I hope you understand it. Now there is a path from 1 to 10. Let us do one thing and let us add one more row. This is row number 10. Let us add one more column. This is column number 10. This is column number 10. Okay. So let us not use this. Zeroth column and zeroth row is not used. Now from 1 there is a connection. There is a path 1 to 10. If there is path, I represent that with 1. There is path from 1 to 10 and then path from 3 to 10. There is path from 3 to 10. So where is 3? This is 3. Where is 3 to 10? There is a path from 3 to 10. Then there is a path from 7 to 8. And this is 7. Where is 8? Here. There is a path. There is a path from 6 to 8. There is a path from 7 to 4. There is a path from 7 to 4. Where is 4? And this is 4. Okay. Path from 9 to 4. 9 to 4. Path from 7 to 6. Path from 7 to 4, 7 to 6. Then 5 to 8. 5 to 8. 1 to 8 and 2 to 8. Okay. 5 to 8, 1 to 8 and 2 to 8. These are the paths. So I hope you understand it. Now number of games played. Number of games played are 5. Now game number 1. 4 soldiers. 4 soldiers. This is game number 1. Just a moment, I'll come back. Sorry for delay and interruption. Well, let us start. There are 10 locations and 10 paths. So I have shown the paths as an adjacency matrix. Now the two majors or two commanders played 5 games. Game number 1, say 5 games. 5 games. Now game number one has four soldiers, and they are at locations 10, 7, 6, 4. These are locations. Now, first major X make first move, major Y makes next move. The first move, major X tries to move the soldier at 10 to possible location. The first player, who is major X, will try to move the soldier from location 10 to next possible location, but there is no path. But there is no path from location 10. From location 10 you cannot go anywhere. Okay, so from 10 we cannot go to anywhere. This is played by X. Now Y, he tries to move 7. He tries to move soldier at 7. Soldier at 7 can be moved to 4. Okay, so X got 0 points, Y got 1 point. Next it is turn of X. Soldier at X 6. Soldier at 6. Is there any path from 6? Yes, there is a path. So X gets 1 point. Now the turn of Y. It is turn of Y. Now very soldier at 4. Very soldier at 4. So is there any path from 4? Is there any path from 4? No, there is no path from 4. So Y loses. Y loses. Okay. So this game is won by X. Next, let us take one more game. Game 2. Game 2. There are 3 soldiers. At locations 1, 9, 4. Now X first x. From 1 there is a path, so I can move u or y. From 9 there is path, yes, you also want it. Next it is turn of me. From 4 there is no path, so I lost. Okay, so this game is won by y. Next game, there are 3 locations and soldiers are at 4, 9, 7. X, Y, X. From 4 there is no path. From 9 there is one path which is already used. The soldier there. Okay, next. No. Yes, already used. 7. 7, yes. This game is won by X. So please respond. The rules are: a move is legal if there is a path. A move from ith location to jth location is called a move. Moving a soldier from ith location to jth location is called a move. If there is path between them, then it is a legal move. If there is no path, it is not legal. Now there are 4 soldiers at locations 10, 7, 6, 4. If I can move a soldier from 10 to next location, I get 1 point. Otherwise, I get 0 point. Okay. So player 1 turn is over. Now player 2. If there is a path from location 7, yes, then player 2 get 1 point. Next, this is player 1. If there is a path from 6, I get 1 point. Then player 2. If there is a path from 4, then player 2 get 1 point, but there is no path. And there is no path. Okay? And all the locations are done. Whoever wins recently is a winner of the game. For legal move, we get 1. For illegal move, we get 0. And one more rule is, if a soldier is moved from I to J, then there are no soldiers at I, and that path is blocked. So let us write a program. So please try to understand, this is the solution is not available anywhere. First, number of locations is 10. Number of paths is 10. Let us create one adjacency matrix with 0 to 10 rows and 0 to 10 columns. J in range Columns are paths, locations, and rows are also locations. This is called adjacency matrix. Create one adjacency matrix. Now, read the paths. Read the paths. Let us call them as paths. Okay. So first path from 1 to 10. Second path. Second path from 3 to 10. Third path from 7 to 8. Next path from 6 to 8. 1 to 10, 3 to 10, 7 to 8, 6 to 8, followed by 7 to 4, 7 to 4, 1 to 10, 3 to 10, 7 to 8, 6 to 8, 7 to 4, say 9 to 4, 9 to 4, followed by 7 to 6, followed by 5 to 8, followed by 1 to 8, followed by 2 to 8. Let us reduce the font size so that you can see clearly. Okay, now say 1 to 10, 3 to 10, 7 to 8, 6 to 8, 7 to 4, 9 to 4, 7 to 6, 5 to 8. Okay. This is okay. Now, for adjacency matrix, for I in range let us not use 0 from 1 to 10, that is n. Okay, now matrix. Say matrix. Let us call destination as u and source as u and destination as v. What is source? Paths I0. This is source. What is destination? First element is source, second element is destination. Okay. Now, for matrix, from node U to node V, there is a path. Okay. Okay. This is showing the information as a matrix. Let us see whether this information is properly taken or not by printing. Say import numpy as np. Now print this matrix. So matrix. For j in range n plus 1, okay, I missed for I in range n plus 1. What happened? For J, I think for is missing. I should put 0 here. U is path size 0. List index is out of say paths are 10 paths only. Okay. Okay, this is adjacency matrix. You can see here from 1 to 10 and 1 to 8 and then 2 to 8, 2 to 8, 2 to 8, 3 to 10. From 4 no path is available. Okay, is this clear? So please respond. This is adjacency matrix. Next, read number of players, number of games or moves. Number of games are 5. Number of games are 5. Okay. Now there are 4 locations. There are 4 locations. Okay. Read those locations. What are those locations? First time, say there are 5 games for I in range. For I in range, number of games. For I in range, number of games. Okay. In each game, read the locations. In first game, there are 4 locations. Second game 3 locations. Third game 3 locations. Fourth game 3. Fifth game 3. So read the number of locations. Okay. Or for the first time, let us do one thing. Let us call a function. Let us call a function and pass the relative positions of locations and the locations where the soldiers are available and number of locations. Okay. Now let us write the function. Function name is fun. Define. Input is the matrix, the locations and number of locations. Find out number of locations. Find out number of locations. For I in range, number of locations. Then for each location search whether there is a path or not. For j in range, path 1 to path 10. So number of paths, path 1 to path 10. If path is available from location I, if path is available from location I to location j, then assume that legal, that is path available, initially path available is false. If there is path, make available true and then break. Okay. Now for safety reasons, a path once taken should not be taken again. For that reason, you make that path 0, that is blocking the path. Make that path 0. Okay. And find out status at that location. Is it legal or not? Initially, let us put 0 for all. If path is taken, then make the status 1. Else status is okay. Now print status. It has run it. A comma. N is not defined. This is small n. So let us small m. This is also small m. This is also let small n. Location spelling. Locations 10, 7, 6, 4. Status equal to 0 for I in range. Matrix. Locations I. LOCATIONS. LOCATIONS. For I in range. Oh, sorry. Number of locations, say n. Number of locations, n. Now this should be clear. Say number of locations is k. Range k. For I in range k. Locations 0. Locations 0. Status I. Okay, I put comma here. See, player 1 in first move got 0. Player 2 player 2 player 2 in second move got 1. Then player 1 in third move got 1. Player 4 got 0 in last move. Okay, so tell me who won the game. Tell me who won the game. So let me know who won the game. Who won the game? Who won the game? So please let me know who won the first game. Player 1 0, player 2 1, player 1 0, player 2 0. Who won the game? So please let me know who won the game. Who won this first game? This is player 1, player 2, player 1 and player 2. So can you hear me? If you can hear me, if you understand this, ask reply to my question. Otherwise, ask me to explain again. I will do that. So let us play all the 5 games. In the second game, there are 3 players at locations 194. This is number of paths available. Sorry, number of locations available. In the third game, there are 3 players available. Sorry, 3 soldiers at locations 835. In the fourth game, 3 players at 497. Sorry, 3 soldiers at 497. In the last game, in the last game, there are 3 soldiers at locations 7, 9, 10. So this game is played for 5 times, and these are number of locations. There are also number of locations. K is number of soldiers. Now you tell me who won this game. Who won first time, who won second time, third time, fourth time. First position is for player 1. Second position is for player 2. Third position for player 1. Fourth for player 2. Look at this solution here. Bhumi is player 1, Airo is player 2. So you are not answering my question. The last player who got 1 in first game is player 1. So let us do one thing. Let us not print this matrix because we already have seen this matrix. Position 0, position 1, position 2, position 3. Position 1 is for player 1, 0 is for player 1, this is for player 2, and this is for player 3, player 1, I'm sorry, this is for player 2. Say game 1, game 1, game 1 is won by position 2, the last one is position 2, won by player 1. Game 2, second position is 1, so won by player 2. Game 3, game 3 is won by, this is position 2, won by player 1. Game 4, position 2, player 1. Game 5 by player 1. Now this is solution. So what we do is we find out who is the winner. If status of I equal to 1, break to get the last one to who won the game. Now if I is even, print player 1, else print player 2. Okay, this is the final solution. So please note down this code and try on your own, and please let me know if there are any issues in it so that I will explain once again. Okay, all the problems we discussed so far are nothing in front of this. But this is in HackerRank. The problem name is play on benefits, play on vendors. Okay, one of the students asked me to do it. Okay then.